Greetings everyone. So welcome to another lecture of circuits and system. So today we are starting up with a new lecture of network functions. In the network function, we are going to go through with what are network function, driving point network function, transfer network function, and few practice questions. Okay. So those questions will be associated with the questions which have just appeared in your recent examination. But before starting, let us go through with a beautiful quote by Dr. APJ Abdul Kalam. He says, end is not end. It means effort never dies. So I request you all to make some effort in the subject and nothing will stop you from getting marks. With this quote, let us start with the first thing. What is network function? So network function is something which gives us a relation between current and voltages at different point of network. So they are broadly classified into driving point network function and transfer function. So what are these driving point network function and transfer function? So to understand this, let us consider two types of network, one port network and a two port network. So at a one port network, we have an input voltage VI and we have a current I1. Okay. Now, when we are concerned with the parameters associated at voltage and current at same port, we generally refer them to driving point functions. And when we are concerned with voltage and current associated at different ports, we are talking about, let us say this is I, talking about transfer function. So transfer already means from one port to another or from one place to another. So moving ahead, let us talk about our driving point function. So we've got two driving point function. One is impedance function and other one is admittance function. So what is my impedance function? My impedance function Z of S is defined as the ratio of voltage at same port by current at the very same port. It is denoted by Z of S. So if you see voltage transform at one port to the current transform at the same port, this gives us driving point impedance, voltage by current. So moving ahead to driving point admittance. So admittance, as you all know, is nothing but Y of S, which is nothing but 1 by ZS, or we can say current transform at the same at one port divided by voltage transform at the very same port. Okay, so this is driving point impedance and driving point admittance. So moving ahead with the topic, we have got transfer function. Now, since we have voltage and current at one end, voltage and current at the other end, so this brings us to two or rather four types of function. First, let us say voltage transfer function. It is denoted by G of S. It is voltage at first or rather say second port and voltage at the other port. It is a ratio of two voltages. Voltage at the second port divided by the voltage at the first port. Second function is your alpha, which is current at second port divided by current at first port. This can always be referred as G21. We can always calculate G12S, where it will be voltage at first and voltage at second. Similarly, this is alpha 21. We can have alpha 12. It would be current at first and by current at second. Okay, so here also we do have impedance function. It is defined as ratio of voltage transform at one port to the current transform at the another port. So Z21S is V2S by I1S. Similarly, Z12S is V1S by I2S. Again, we have an admittance function which is nothing but 1 by ZS is equals to Ys. Now, can we have the driving point function at the two-port network as well? Yes, we can have. That's why I use the term generally driving point are associated with one port, but they do have at the two-port network as well. So let us just consider this. Okay, so let's just go back. Okay, so here, can I just say that this is voltage and current at the same point Z11, voltage and current at the same point Y11? If it would have been a two-port network, we are calculating Z21 and we are calculating Z12. So these are the network functions. So let us just take an example. So in this example, we have been asked to calculate voltage transfer function. So voltage transfer function always denoted by G21S. It is denoted by G21S would be nothing but V2 by V1S. Okay. So before going up, let us just revisit one thing which is known as voltage divider rule. So let us just revise this first because it will become easier for you to handle the question. So let us say we have got two resistance. We have a voltage V1 over here. We have a voltage V2 over here. And we need to know this voltage VA. So let us just be R1. This would be R2. So what would be my VA? My VA will be V1 multiplied by R2 plus V2 multiplied by R1 divided by the total impedance. So this is nothing but my voltage divider rule. So using the same rule, so can I say this point will be nothing but V2S? This is nothing but ground. So at this point, using the same rule, voltage divider, we'll calculate V2S. So my V2S will be V1 multiplied by 1 by CS, V2, which is already 0, multiplied by this. So this ratio becomes 0 divided by the total impedance, 1 by CS. Solving this, we get V2 by V1. It would be 1 by RCS plus 1. This becomes my G21S. So simply what we have used a voltage divider rule and we have moved ahead. So question. So this was a part of your question in 2015 where we need to find out G2S. G21S. So it would be V2S by V1S. So we have got V1 over here, we have got V2 over here. So to solve this question, if you just start considering this thing as open source, so we have 2 points of voltages. Let us put this as VA. Now at this point, if you see, there's no current in this part because this is an open circuit. So there will be no voltage over here. So can I say this point as V2? So this will also be V2S. So can I write this thing G21S as V2S by VA multiplied by VA by V1? Okay. Now solving for the first part. So at point, let us put this point as B, this point as capital A. At point B, applying voltage divider. Okay. So at point B, if we apply voltage divider, so it would be V2S by VA. So VA into 1 by 2F. So if I have to apply voltage divider, I have to convert these sources into their equivalent S transform form. So this would be 2 of S. It would be impedance of this capacitor. This will be 2 of S. For my inductor, this would be S, this would be S, and this would be S. So at this point, VA into 2 by S divided by the sum of impedances, that is S plus 2 by S. So V2A by this will give me 2 by S square plus 2. So this becomes my first part of this equation. I've got V2 by Vs. So to finding out VA by V1, so if we see at point A, so at this point, if we see the impedance of the whole circuit will take into place. So here there is no current, hence this L, this C, and these C, all these things will be taking part on the voltages over here. So I can just redraw this network and I'll put this thing as Z. So this becomes my V1. This one was my first inductor. This is point A where I'm calculating a voltage VA. So for calculating VA, I need this Z first. So for calculation of this Z, if you see this inductor and this capacitor are in series and in parallel with this capacitor. So my Z would be nothing but 2 by S plus, okay, not plus, rather it would be 2 by S multiplied by S plus 2 by S divided by S plus 2 by S plus 2 by S. So simplifying the equation, so I get 2 by S square plus 2 by S whole divided by S square plus 4. So 1S get cancelled. So I get Z is equals to 2 plus S square plus 2 divided by S into S square plus 4. So I've got the value of Z. This S is over here. It's cancelled from there. Now calculating the value of VA by V1. So my VA by V1 would be given by Z over my S plus Z. So if you see it carefully, I've just applied a voltage divider rule over here. Okay. So substituting the value of Z, my Z will be 2 S square plus 2 divided by S square plus 4 over S plus, this is Z, over S plus 2 S square plus 2 by S into S square plus 4. Okay. So solving for this equation. So I get 2 S square plus 2 whole divided by this comes up. So S into S square. This will be S4 plus, we'll have 2S square over here, 2S square, and 4S square over here. We'll have 6S square plus, we'll have 2 plus 2 into 4 plus 4, 8 over here. Just take down the calculation. Okay, I'll just solve it. Okay, wait. I just need to solve this. Okay, one by. I'll just solve this for you. I'll just solve it for you. So overall it would be 2 s square plus 2. This will come up s cube plus 4s. So it will be s4 plus 4s square plus 2s square plus 4. Okay, so this will give me 2s square plus 2 divided by s4 plus 6s square plus 4. So this I've got VA by V1. So now multiplying this VA by V1 by this will give me G21S. So if you see it carefully, this factor and this factor gets cancelled. So what do I get? I get 4 S4 6s square plus 4 as G2S. Okay. So if you can see, I'll just mark it with some different colors so that you can take a screenshot of it. This and this get cancelled. 2 multiplied by 2 and denominator remains same. This gives me x square. So you can just take a screenshot of it, go through it once, you'll be able to crack. So this is all about your network functions. Moving to the end. So just always remember, my dear friend, a journey of 1,000 miles begin with the first step. Consider this video as the first step. Do like it, share it, and subscribe the channel so that we can expand our universe for you. Thank you.